Welcome. In this video, I will show you an Excel sheet, which is used to solve simultaneous linear equations by the Gauss-Jordan method. When you first open this spreadsheet on your computer, you will get a security warning stating that the file contains macros. Thus, click where it says, Enable Content. We recommend that you never download our files from unauthorized websites as they will malfunction or may contain viruses. Always download the files from our official networks. Having said that, let us begin. To use this spreadsheet, we'll start with learning how to identify the data. The cells whose numbers are colored blue are the input data. The data in black are the titles. And those in red are the output data. There are also the buttons that will perform different functions. And as an additional tool, there are the buttons to change the language, from English to Spanish and vice versa. In this video, we will explain 3 examples to see how it works. As a first example, we have this system of equations with 3 unknowns. It corresponds to a 3 by 3 matrix. Before entering the new matrix, we will delete the existing data. To delete the existing data, we will click on the button that says, Delete Matrix. Once you have clicked the button, a text box will appear advising that it recommends that you copy and paste the current matrix in another file, in case you need to use it in the future, since you will not be able to recover it. Having said that, we click Accept. Note that this action cannot be undone, so we recommend always having a copy of your data, especially when dealing with big matrix. We proceed to enter the new matrix. In this case, since the matrix is 3 by 3, we will enter the number 3 here. Then we proceed with the tolerance value. This should be a value as close to 0, for greater precision in the results. The current value is accurate, so we'll leave it that way for all examples. Finally, we will enter the data of the matrix. We begin to enter this data from cell 8,1, or A8. Note that independent values must always go to the right side of the coefficient matrix, just as you would type it manually. So that the system of equations can be well appreciated, once the program has been executed, it will shade the matrix values with one color, and the independent values with another color. The latter will be in italics and bold. We will check it by clicking the Calculate button. Now we can see how the program identifies the matrix of coefficients of one color and the independent values of another color. If we want, we can remove the color format by clicking on the button that says, Delete Colors, so that it returns to its original format. Here we can see the results in this row. The first result corresponds to the value searched for in the first column. The second result corresponds to the value searched for in the second column, and so on. We can also see the output message, which will indicate if the program was executed correctly, or if an error has occurred. Or it may be the case where a text message appears indicating runtime errors. Finally, we see the value of the determinant. This is important since, if its value is 0, it means that the system of equations has no solution, or it has infinite solutions. If its value is close to 0, there may be imprecision in the results. To verify that the solution was correct, we must multiply the results by their corresponding columns, and add the values of each row. To do this, we proceed to temporarily create a formula in this cell. We write the equal symbol. We select the first result that is in cell 6,1, or A6. We press the F4 button twice so that this cell does not change when we drag the formulas downwards, but it does change when we drag it to the right. Then we write the asterisk symbol to multiply, and we select the first number of the first column of the matrix, which corresponds to cell 8,1, or A8. We press Enter, and with this we have the formula program. Since the matrix is 3 by 3, we first drag the formula 2 cells down, and then 2 cells to the right. With this we get that all the numbers in the columns are multiplied by their corresponding result. Now we have to add each row of the matrix. To do this we select the blank cell that is to the right of the first calculated row, and press the AutoSum button. This will add up all the values in the row. We press Enter, and finally we drag the formula to the last calculated row. We can see how these results coincide with the matrix of independent values. This means that the calculated values are correct. Now we go with the second example. This will be a 4 by 4 matrix. We delete the existing matrix and add the data of the new matrix. Do not forget to write the number of unknowns, which in this case is 4. We click on Calculate, and we get the results. To verify the results, we do the same procedure as in the first example. We create the formula, multiplying the values of the column with their corresponding result. We drag down. Then we drag to the right, and add all the rows. In this way, we can check that the results are correct, since they coincide with the matrix of independent values. Now, we go with the third example. This will be a 9 by 9 matrix. We copy the data. We write the number of unknowns. We execute. We verify. And we check the results. We see that the values match. If you want, you can skip the verification step if you trust the results that the program calculates. This sheet can solve matrices of infinite size, depending on the capacity of your computer. However, the buttons for clearing data, clearing colors, and formats are programmed for a maximum 100 by 100 matrix. In the description we will leave the links in case you want to see the step-by-step solution of these examples. That's all. If you want to visit our website, you can click on the link in the first row. Also, if you want to support us with a donation, you can click on the image of the PayPal button, or click on the link that is in the description of this video. Always make sure that the donation link matches the one displayed on official social media. To get this file, you can click on the links shown in the description. If you liked the video, give us a like, and share it on your social networks. Don't forget to subscribe and activate notifications to receive more content from our channel, Civil DCP. Thanks, and see you soon.